Dear students, welcome to today's session. In the last class, we have seen how a return statement affects the value of a main function and what are the categories of functions based on the return value and the different types of parameters. And then we have discussed about the differences between actual and formal parameters. Then we have seen how the value is passed to the main function from the sub function. So now today we are going to discuss about an important concept which I had started in the previous session, and let's continue with this. Now storage classes, as I discussed in the previous session, it gives you the scope of the variable, correct? The storage class of a variable actually defines the visibility of the scope and lifetime of the variable and or with respect to the function which is declared within the C program. So in addition to this, the storage class gives information about the variable or the function. It is basically used to determine the part of the memory where the storage space is allocated for the variable or the function. That is, whether the variable or the function will be stored in a register or in a RAM is showed here in the storage classes. And it also specifies how long the storage allocation will continue to exist for that function or variable, and it also specifies the scope of variable or function, that is the part of the C program in which the variable name is visible or accessible. The another important thing that is specified by the storage classes, it specifies whether the variable or the function has an internal, external or no linkage, and it also specifies whether the variable will be automatically initialized or to 0 or to any other intermediate value. So let us understand this with the classification. So basically the storage classes is classified into 4 different categories, that is auto, extern, register and static. So we will see how the variation is showed for these 4 categories of storage classes with respect to accessibility, storage, existence and default value one by one. The auto storage class, it is accessible within the function or block in which it is declared, and the storage is always in the main memory for this, and exists when the function or a block in which it is declared is entered, and it ceases to exist when the control returns from the function or the block in which it was declared, and the default value of this storage class is garbage. Now coming to extern, with respect to accessibility, it is accessible within all the program files that are a part of the program, and the storage space is allocated in the main memory for these set of variables, and it exists throughout the execution of the program, and the default value of this is considered to be 0 always. Now coming to register, the accessibility is within the function or block in which it is declared, and the storage space allocated here for this is CPU register, and it exists when the function or a block which is declared is entered, and it ceases to exist when the control returns from the main function or the block in which it is declared, similar to the auto storage class, and default value for this is garbage. Now coming to the last category, that is static. Here local accessible within the function or block in which it is declared, and if it is global then accessible within the program in which it is declared, and the storage space is allocated for here is in the main memory, and if it is a local variable then it returns the value between the function calls or block entries, and if it is a global variable it preserves the value in the program file, and the default value of this particular class is considered to be 0. So this table is showing you the different features of the storage classes with respect to the 4 parameters, that is accessibility, storage, existence and default value. Now we have understood how the storage classes is classified based on the variable parameters, and now we will take up another important concept with respect to function, which is named as recursive function. So recursive function is a function that calls itself to solve a smaller version of its task until a final call is made, which does not require a call to itself. So here multiple times the same function will be called. So every recursive solution has two major cases, that is base case and recursive case. So base case is one thing in which the problem is simple enough to be solved directly without making any further calls to the same function, whereas recursive case is one in which the first problem at the hand is divided into smaller subparts, and second the function calls itself but with subparts of the problem obtained in the first step, and third the result is obtained by combining the solution of all these subparts. So therefore recursion is defining larger and complex problems in terms of a smaller and more easily solvable problem. So in recursive function, complicated problem is defined in terms of simpler problems, and the simplest problem is given explicitly. So let us understand this with an example. Now here we are considering a task where we are trying to find the factorial of a number using recursion. As you know the concept of factorial, so if I consider 5 factorial, it is nothing but equal to 5 into 4 into 3 into 2 into 1. So here using the recursion, first what we will do is first initially we will calculate the product of two numbers, then it is like n into n minus 1. So factorial is always taken as n into factorial of n minus 1. So here the base case is considered as n equal to 1, because when n is equal to 1 the result is known to be always 1. So it is the base case. Now we are going to multiply n with n minus 1 and so on, it continued. Okay, so n is multiplied with factorial of n minus 1. So base case is initially considered for the function, and then the results will be displayed in the main function. So here we are defining a function with the name as FACT, and the return value is of the type the integer, and the input value is also in the type of integer. Now first case what we are going to take, which is nothing but the base case, so that is if n is equal to 1, the factorial of n, as we know it's always equal to 1, the return value will be 1, else the return value will be taken as n into fact of n minus 1. So the factorial of this is evaluated and it is returned to the main function. So here we are reading the number in the main function, and then we are taking a variable as factorial. Now multiple times the same function will be called, so that we are going to take the value as n into factorial of n minus 1. This is called as recursion. So we are reading the number and we are calling the function in the main function, and that is assigned to the variable factorial and that is displayed. So you can see here the return value will be always n into n minus 1. So when I give n as equal to 2, so it is taken as 2 into factorial of 1. So next similarly if I give 3, then it is taken as 3 into factorial of 2, and it continues like this till we get the factorial of the nth value, which is given in the main program. So this is one important program which is based on recursion, which is telling you how the function is calling itself in order to evaluate the value recursively. Now let us now consider the types of recursion what we have. So any recursion can be characterized based on whether the function calls itself directly or indirectly, which is named as direct or indirect recursion, whether any operation is pending at each recursive call, which is called as tail recursion or not recursion, and the structure of the calling pattern, which is known as linear or recursive function. So we have the categories like this: direct and indirect, linear or tree, and tail recursion. So we will understand these recursion types one by one with example. Now first is direct recursion. So a function is said to be directly recursive if it explicitly calls itself. For example, as we know, we have seen in a function where we are finding the value like this. So integer function, integer value, if n is equal to 0, the return value is n, else the return value will be function of n minus 1. So the function is calling itself directly. Okay, this is called as direct recursion. Now in indirect recursion, the function is said to be indirectly recursive if it contains a call to another function which ultimately calls it. And we can have two functions here in this case, function 1 and function 2. We will understand how your functions are called indirectly. So as you can see here, int function 1 is calling function 2. So one function is calling another function. This is called as indirect recursion. So A call for another function is included in one function. This is called as indirect recursion. Now coming to tail recursion, the recursion function is said to be tail recursive if no operations are pending to be performed when the recursion function returns to its caller. So we are not supposed to have any pending operation in case of tail recursion function. That is, when the called function returns, the returned value is immediately returned from the calling function. And tail recursion functions are highly desirable because they are much more efficient to use, as in their case the amount of information that has to be stored is on the system stack and it is independent of the number of recursive calls, so it will not have any pending operations. That is called as tail recursion. And linear and tree recursion, its recursive function can be characterized depending upon whether recursion grows in a linear fashion or in the form of a tree structure. In a simple words, we can define a recursion function is said to be linearly recursive when no pending operation involves another recursive call to the function. For example, factorial of function is linear recursion as the pending operations involved only multiplication to be performed and does not involve another call to the factorial. On the other side, a recursive function is said to be tree recursive or non-linear recursive if the pending operation makes another recursive call to the function. So, for example, in Fibonacci sequence, the fib will be called with the pending operations recursively calls the another fib function. So, this is about tree recursion, and we will see the pros and cons of this recursion. The pros of recursion are recursion solutions often tend to be shorter and simpler than non-recursive ones, and the code is clearly and easier to use. And recursion represents like the original formula to solve the problem, and it follows a divide and conquer technique to solve the problems. So in some instances recursion may be more efficient. The concepts for some programmers, the readers, recursion is difficult concept. Okay, and recursion is implemented using system task, and if the task space on the system is limited, recursion to deeper level will be difficult to implement. And aborting a recursion process, it emits steam and it is slow, and using recursion function takes more memory and time to execute as compared to the non-recursive counterpart. And it is also difficult to find bugs, particularly when we are using the global variables with respect to recursion. So these are the pros and cons of recursion function. Now this is the Tower of Hanoi. So the Tower of Hanoi is one of the main application of recursion. It says if you can solve n-1 cases, then you can easily solve the nth case. So here we have the cases like ABC. If there is only one ring, then it is simple to move from one ring from source to the destination. But here if we have two rings in the below the diagram, if there are two rings, then first we are supposed to move ring 1 to the spare hole and then move ring 2 to the source to the destination. Finally move ring 1 from the source to the destination. This is called as Tower of Hanoi, where it is showing you the recursion, how it is moved from one place to another place. So the same example is shown with three rings. So first we'll be moving the first one, and the second one is moved to the second place, and the third one, then we'll be moving the last one, and then further these two will be moved, and finally we are going to reach the tower. So this is showing you the application of recursion, how the movement is done. Now this is the second topic of module 4, which is named as file handling. So file is defined as a collection of data stored on the secondary device such as hard disk, and file is type defined structure, and it is defined in a header file stdio.h. And the file is considered to be a derived data type, and file is not a basic data type in the C language. So we have three different types of files, that is input file, output file, and text file. So input file, it's a file that contains the same items that might have typed in from the keyboard, and output file contains the same information that might have not been sent to the screen as the output from the program. And a text file or a data file is the one where the data is stored as a stream of characters that can be processed sequentially. So these are the four different types of files. Now we'll see how to handle these type of files. And we have few steps that is used to perform the file manipulation. Declare a file pointer variable, open a file, read the data from the file and write the data into the file and close the file. Now we declare a file pointer variable, so with an operator, that is pointer operator star p. Like all the variables declaration, they are declared before they are used. A file pointer variable also should be declared before it is used. And file pointer is a variable which contains starting address of file, and it can be declared using the syntax which is shown below. So we are supposed to mention the file name followed by star p. So this is the syntax which is shown here. fp is nothing but a pointer to the file. Now we'll see how to open a file. So the file should be opened before reading the file or before writing to the file. So file pointer should be declared first, and when we are going to use the inbuilt function file open, so where the file will be opened with the file name along with the mode. So fp is the file pointer. So fopen is a function which opens the file in any of the three modes, that is read mode, write mode or auto mode. So fopen function will return the starting address of the opened file, and it is stored in the file pointer. So if the file is not opened, then the fopen function will return a null value. So and error we can print it as the error in opening the file. So here these are the three modes of operation we have, that is read mode, write mode and append mode. So R mode opens a text file for reading, and but here to open a file first the file must exist, and W creates a file for writing, and A it appends a text to a file. So in the read mode, your file will be opened if it is, and the file must be available to perform read operation. And the various features of this mode are: it is used only for text file, and if the file does not exist, an error will be returned, and the contents of the file are not lost, and the file pointer points to the beginning of the file in read mode. So this is the thing which is shown in the form of a block diagram. File position after opening is in the top of the file, and once it is read, it will be in the end of the file. And in write mode, this is used to create a file for writing. The various features of this mode are: if the file does not exist, a new file will be created. If a file is already exists with the same name, the content of the file are erased and the file is considered as a new empty file. The file pointer points here also to the beginning of the file if you want to perform a write operation. And append mode, this mode is used to insert data at the end of the existing file. The various features of this mode are: it is used only for the text file, and if the file already exists, the file pointer points to the end of the file, and if the file does not exist, a new file is created, and existing data cannot be modified in this particular mode of operation, that is in the append mode. So these are few examples of the program where here the file is opened in the read mode, and here the file is opened in the write mode. So we have a file which is opened with the name as civil.txt, and it is in the read mode. So if fp is equal to null, we are going to print the message as error in opening the file. And fclose is a function which is used to close the file. And here we are opening a file called as ecb.txt. This is for the write mode. So here also, if fp is equal to null, it will print the message as equal to 0. Otherwise, whatever data you want to write, you can write in this particular file in the write mode. So this is an example of an append mode. We have opened a file in the append mode. Here whatever data you want to include, it will be included at the end of the file. So closing of a file. So when we no longer need a file, the file should be closed, and this is the last operation to be performed on a file, and a file can be closed using the function fclose function. So if a file is closed successfully, value 0 will be returned, otherwise end of file will be returned. So this is about management of files. Now, there are three types of IO functions that is used to read or write data into the file. So, file IO functions includes fscanf, fprintf, and with respect to strings, we have fgetString and fputString, and with respect to character, we have fgetCharacter and fputCharacter. So, we will understand this in the next session. I've just given an introduction here.